So, for example, here we've got some footprints in a sandstone in the Grand Canyon. There's a little bit of an outline of the little guy. It's basically a labyrinthodont footprint, a type of amphibian. You've got several of them here. 1, 2, 3, 4. There's the trackway of the little fella. And the direction of trackway is indicated by those prints that I pointed out, but the individual prints are actually faced at a slightly different angle than the trackway is. So he seems to be walking kind of cockeyed to the direction of the trail, which suggests that there is a current of water. Water is moving along and pushing him. This is probably not in wind situations. It's got to be in water, especially since this particular animal is a very low-lying animal. So the evidence is that there must be a water current that is causing him to put his feet, orient his feet upstream so that he doesn't slide away, so that he isn't washed away, and then make his way across the current at an angle. From this, we can determine the direction of current, the type of current that animals experienced. If we look at dinosaur prints, for example, we find that the quality of the dinosaur prints suggests that they were formed underwater. Furthermore, a second observation with footprints is when you find a given organism in the fossil record, typically you'll find his footprints before you find his body fossils, before you find his bones, or before you find his shells. For example, when you first find trilobites in the fossil record at the base of the Cambrian, the very oldest rocks that contain animal fossils, you don't find the shells of the trilobites, you find the footprints, what's called Cruziana. In the lower left there, we have a picture of Cruziana footprints. They're the little trackways that little guys make. You have to go up the stratigraphic column some distance, in some cases several dozens of feet, to finally get the first shells. And these shells are made of calcium carbonate. I mean, these shells are pretty solid. They're made of limestone. It should be easy to preserve them if they were there, yet what we have are footprints that occur for a number of layers before we finally get the bodies. Same thing happens with the dinosaurs. The very oldest evidence we have of dinosaurs are footprints. It isn't until later that we get the bones. It would seem, in the face of it, that it would be easier to preserve bones than it would be to preserve footprints, but the fossil record shows footprints before bones. I would suggest that what this is referring to is that organisms are escaping from a catastrophe. They're running for their life while sedimentation is occurring very rapidly. So you see their escape trackways before you finally get their bodies at a higher level. So the footprints that are formed underwater and formed before the body fossils suggest that we have both terrestrial and marine organisms overwhelmed by this catastrophe, which is consistent with the global flood we have mentioned in Scripture. Another issue is the issue of disparity before diversity and stasis before abrupt appearance. The difference between disparity and diversity. Diversity is the number of organisms that you have. It's how many different species you have. Disparity is how different those species are. In an evolutionary perspective of things, organisms, in fact, change through time according to an evolutionary tree. New species come in slightly different than species that were already there, gradually branching out, gradually becoming more and more different from the original species. So in order to create great disparity or difference among and between organisms, you have to actually branch a number of times before you can get there. On the way, you're increasing the number of species. So it should be that you cannot produce in evolutionary theory great disparity before you've already produced great diversity. So as Stephen Jay Gould and others have said, with evolution you would expect diversity to appear before disparity in the fossil record. But alas, what fossils show over and over again is high disparity at the beginning, long before we get any diversity. For example, the oldest arthropods, some of the oldest arthropods in the world are found in the Burgess Shale. Beautiful preservation, so well preserved that you can actually dissect the individuals as fossils with their internal parts. It's just extraordinary stuff. In the Burgess Shale, if you set aside the trilobites, there are 21 species of arthropods that have been described, and they represent 20 different classes of the phylum Arthropoda. So the major groups of arthropods, that's the highest classification of arthropods, at basically the first level that you find arthropods at all, you find 20 different classes. There are only 5 classes of arthropods in the present. And there's only 21 species representing 20 different classes. That's huge disparity. That's more disparity than you in fact have in the present arthropods. And they're represented by only one more species than there is disparity. That is not what you'd expect in evolutionary theory. The same thing is seen with the echinoderms. You have a very large number of echinoderm classes that appear when you first see the echinoderms. You have fewer echinoderms in the present, and you have a very low diversity of echinoderms when they first appear. The fossil record shows the opposite of what evolution predicts. It shows disparity before diversity. But I would suggest that the observation of disparity before diversity fits a flood account, because if the flood is coming in and, let's say, picking up entire ecosystems and carrying them and burying them, when it picks up an ecosystem, the ecosystem has a very high disparity. It has trees, let's say it's a terrestrial ecosystem. It has trees, and it has insects, and it has, let's say, mammals, and it's got fish in the little streams, and it's got bacteria, and it's got a very high disparity. Compared to the diversity of the world, it's got a very low diversity. So it's got very high disparity, the full disparity of life, and yet a relatively low diversity. So if the flood picked up a community and dumped it in place, the first community it laid in would in fact have very high disparity with relatively low diversity. It's exactly what the fossil record shows. On the issue of organismal change, evolution in fact predicts gradual change of one organism to another. So if your A is going to evolve into B and C, you would expect a series of transitions between A and B and A and C. And it would expect that the divergence could be seen between B and C as things go up in the fossil record. What fossils actually show, though, is not this gradual change and divergence. Fossils show stasis and abrupt appearance, as Stephen Jay Gould used to describe it. Stasis means that when you find a particular species in the record at one level, the oldest one you've got, it stays the same. You find the same species throughout its entire range, and then it disappears. You don't find the species changing at all. It is in stasis. And when you first find the species, there's no transition evident in the fossils from any other species. So it's sudden appearance and then stasis through time. And it's not just true of species, as Stephen Jay Gould argued. It's actually also true of every taxonomic level. Now, I would say this is certainly not something predicted by evolutionary theory, but it is expected with a flood. Because if, in fact, you have a world already full of organisms, and you take that world and dump it into the fossil record, every time the fossil record in that sense has sampled from the world, let's say it's sampling dogs, It comes and samples a dog and buries him here, and then buries him here and here and here. Since it's all from the same species, because they all lived at the same time, they should not change up through the record. You would expect stasis with a flood model. Also, what's the likelihood that the first time you picked up that dog, there would be any other fossils that had just been laid down that look like you're transitioning into a dog? That would be extremely improbable, if not impossible altogether. So the disparity before diversity, the stasis and abrupt appearance, which is very common among organisms, suggests that we have what is called a global life assemblage. It's a living group of organisms, living communities, living ecosystems and biomes across the world that are picked up suddenly in a flood and dumped and buried. So you've got the high disparity with low diversity from such a living assemblage. You've got the stasis and abrupt appearance from the same thing. So we have evidence of, so far, catastrophe, rapid burial, strong east-west current, global flood, and global life assemblage. Then we